Okay, so I want to add two rational expressions, and if I look to add, the rule is I must have the same denominator. These are obviously not the same denominators, so I'm going to need an LCD. So again, because this is algebra and we have binomials, the easiest way to find the least common denominator is to break them down into primes, which is factoring. So recall, how do you factor m squared minus 1? That is right, that's a difference of perfect squares. So I'm going to put my two parentheses, and I'm going to write my conjugates. M and M, 1 and 1, one gets a plus, one gets a minus. That is my denominator factored. How do we factor 5m plus 5? We have a GCF. We're going to pull out a 5. That's going to leave us m plus 1. So now our denominators are in factored form. I'm going to cross these out. They're gone. They're in factored form. Now it's easy to find the least common denominator. The least common denominator, which would mean I may need a number, a variable, or what's in parentheses. Well, the only number out here by itself is 5, so we're going to need a 5. There are no variables by themselves. In parentheses, this denominator has an m plus 1, this denominator has an m plus 1. So we're going to need one of them. This denominator has one m minus 1. This denominator has no m minus 1s. So we take the most. We need that term too. So our least common denominator is going to be 5 times m plus 1 times m minus 1. And we're going to leave it connected by multiplication because that's going to make it easiest for us to make our equivalent fractions. So now we did the first part. Adding fractions, easy as can be. All you need is an LCD. We did it. We found the least common denominator. Now the song says, if you change the denominator, you must change the numerator. Don't look at the original denominator. Look at the factored form. Here's the denominator in factored form originally, and here's the new one. Well, obviously they're different. This new one has a 5. So that's what we're going to multiply our numerator by. We're going to multiply by 5. So 5 times m minus 1 would be 5m minus 5. We're going to distribute. All right, we'll go over here. Here's the old denominator in factored form. Here's the new denominator in factored form. It's easy now to see what we multiplied by. Well, we already had the 5. We already had the m plus 1. So this is what we multiplied by, m minus 1. How do we multiply 2 times m minus 1? We distribute. 2 times m is 2m. 2 times negative 1 is negative 2. So now you've written two equivalent fractions. Now we're back to the beginning of this module. Once we have a common denominator, all we do is write the bottom. So the denominator is 5m plus 1, m minus 1. We collect the top. So in the numerators, we have 5m minus 5 plus 2m minus 2. We have 4 terms in the numerator. Can we put them together? Sure we can. 5m plus 2m would make my numerator have a 7m. Negative 5 minus 2 would make my numerator have a negative 7. So now I collected my numerator under this denominator. But the song's not over. After you write the bottom and collect the top, now you're supposed to reduce. Reduce means to do division. Well, we've been through this. You cannot do division unless you're connected by multiplication. 7m minus 7 is not connected by multiplication yet. So we're going to have to factor. What rule of factoring do you all see? I hope you see a GCF of 7. So if we pull out a 7, we'd have m minus 1. So if we factor the numerator, now look what happens. We can do some dividing. M minus 1 divided by m minus 1 is the same binomial. So dividing the same binomial cancels out because it makes a 1. So this final algebra expression, when we add these two rational expressions, our final sum is 7 over 5 times m plus 1. And there you go. Voila. Hope you enjoyed it.